Yeah, thank you. Yeah, so thank you for the introduction. I'm going to jump right in and talk quite fast. Apologies in advance. So we at Expedition signed up to Structural Engineers Declare, and lots of organisations across the industry did the same. When we did that, we were declaring both a climate and a biodiversity emergency. And lots of us have got a bit of a grip now on how to measure, monitor, reduce carbon in our work, but our understanding on biodiversity and how we impact that has got some catching up to do. And our response to this, and having signed the declaration, was to do this piece of research on embodied biodiversity impacts of common construction materials. It was co-funded by us at the Useful Simple Trust and by the IC's R&D Enabling Fund. And we created the concept of embodied biodiversity impact because awareness of biodiversity impact on site was kind of increasing through biodiversity net gain. But we felt there was a bit of a gap in what was happening with biodiversity off-site. And the knowledge around that. But we do know some things. So what do we know about biodiversity impact offsite? We know that steel making is an energy and chemically intensive process which requires mining for raw materials. We know that concrete production requires quarrying of limestone and aggregates if it's not recycled. And we know the timber can be grown in monocultures, which don't support biodiversity, and they can be in areas of forest that have been cleared for production. And we know that the consumption of all of these materials is set to increase in the coming years. And so we know that in our consumption of materials in the construction industry, we're impacting biodiversity. But why is it important? Why do we need to protect it? It underpins the resilience of the ecosystems that we depend on. These 5 sources of value are taken from the landmark 2021 Dasgupta review. As well as that, people have been estimating the financial benefit of biodiversity as being around $33 trillion per year. So whichever way you cut it, biodiversity is really important. But biodiversity is in crisis. We have entered our 6th mass extinction event, which is the first that's caused by human activity. Previous mass extinction events have wiped out 95% of all species, and it's taken ecosystems millions of years to recover from them. And in the UK, we have led the world in biodiversity destruction, and we're one of the most biodiversity depleted countries in the world. And the construction industry has been a part of that. So it's been a significant contributor. The World Economic Forum identified the built environment as one of the 3 systems responsible for over 80% of global biodiversity loss. Infrastructure in the built environment impacted 29% of threatened and near threatened species, they reported. So as well as there being a big magnitude of impact from the built environment, it's happening in sensitive places where there's precious biodiversity. So it's 2 important aspects. And all of that kind of brings me to the research question. So as I said, we're kind of beginning to understand and change how we're affecting biodiversity on site with biodiversity net gain. But we think there's a kind of analogous thing that's like operational carbon, and that we discovered that embodied carbon was as important and becoming more significant as we tackled operational carbon. So what's the equivalent with biodiversity that's happening because of the life cycle of the materials that we're using? So to continue that analogy, we need to think about the whole life cycle. A key difference, though, is that with carbon, it is released and it contributes to atmospheric carbon levels and has a kind of global effect. Biodiversity, the same activity happening in 2 different locations can have a very different level of impact. And so there's a local effect, which makes it a kind of degree more complex to quantify or measure. So for us who are working in the built environment, similar to carbon, we can influence the biodiversity impact of our projects through the decisions that we're making about materials. And we've seen how this can work with carbon, although we know there's lots still to be done and been talked about today. We need to broaden our focus to include biodiversity as an essential part of being a profession that's going to be fit for the future and the challenges that we face. So now to kind of get onto our research a bit more, the approach that we took, we wanted to draw useful conclusions for the construction industry, even though this was a very early piece of research on this topic. To do that, we adopted this COM-B model of behaviour change. So we considered the capability, opportunity, and motivation. to create behaviour change, and that gave us a kind of practical framework to draw our conclusions against, which I'll show you a bit later. Kind of in terms of the steps that we took, we used the UN's 5 biodiversity pressures. You can see on the left-hand side in the green box, there's only 4 listed there. That's because the 5th is carbon, and we wanted to kind of put that to one side for this paper. So we considered life cycle impacts on land use change, direct exploitation of species, pollution and invasive species, and use those as kind of lenses to look at the manufacturing, transportation, installation processes for common construction materials. So taking concrete as an example, we stepped through this process. We defined the assumptions, we mapped the life cycle, we found evidence against those 4 UN key pressures, and then we rated the severity of the impact, and we worked with a biodiversity expert for those steps 3 and 4. And we did that for each of those 5 materials at top. So concrete, steel, timber, earth, and asphalt. We presented our research in this diagram. So it describes the impact across the life cycle. We also summarised our research, the assumptions in our research and the key findings. There's no way you'll read this, so please have a look at our report to read it properly and to see our conclusions for the other common construction materials. There's a lot in there and a lot of detail. So yeah, please have a little look at that. We also in the report set out steps for the industry. Like I said, we wanted to kind of have some practical actions we could follow. This is the condensed version where there's 4 key actions focused around reducing extraction of raw materials and ensuring extraction is done responsibly, where we have to understand our supply chains and engage with them. And we published this research over a year ago now. We've had lots of conversations since. And one of the things that we've kind of come to conclude is that it aligns really closely with this diagram that the ISDRT have given us permission to reproduce. It's their hierarchy of net zero design. And I think so both carbon and biodiversity, this is a kind of guiding light that we should be talking to clients and design teams about on all our projects. And we should be working to push ourselves up that hierarchy as high as possible to minimize our impact on those things. So yeah, finally, to have a look at our report, like I said, also have a look at the UK GBC's Embodied Ecological Impacts website. They've done a great piece of research that sits alongside ours really nicely. Yeah, thank you.